Dear fellow coders, welcome to One Little Coder. Imagine a world where you don't have to have Python installed on your machine, but you still can actually open a Jupyter notebook, write some Python code, save it, and then download it whenever you want. You don't need Python at all. So imagine such a world, and that world is a reality today with JupyterLite. JupyterLite is a JupyterLab distribution that runs entirely in the browser, built using JupyterLab components. But the reason it is able to run entirely in the browser, thanks to WebAssembly. WebAssembly, which is also known as WASM, is nothing but a new type of code, and it helps you run things on the web. So instead of me trying to explain what is WebAssembly, let me take you to an article that I read, which I found good, which is by Argya. So what is WebAssembly? So basically WebAssembly is like a new low-level code, or it's not necessarily a code, it is more like a target compilation code. So what do I mean by that? So you write code in a particular language, C, C++, Java, Python, or any of these languages, and then you can convert this code or compile this code into WASM, and this WASM is now run on a WebAssembly virtual machine. And now this virtual machine can take this code, which is actually written on a different language but compiled to WebAssembly, and run it in near native speed, and it can run on any machine, whether it is like your Windows machine, whether it is your Mac machine, whether it is like latest Mac's M1 machine, or even your ARM devices. So whatever the type of final devices, this WASM or WebAssembly lets you run the pre-compiled code in any place, but yeah, of course a browser. So which means irrespective of whether you have a mobile device, whether you have got something like a tablet or computer, you can actually create near native speed applications without having to write on the same native language. But instead of you having to still write a WebAssembly language, you can just write it on your own language and compile it and then finally run it. That is enough for this video for you to understand what is WebAssembly. But it is not just simply WebAssembly enabling this. There is actually a Python stack that is compiled to WebAssembly. So Pyiodide is a Python stack, I should say, or like a library. So where you have got the Python scientific stack like SciPy, NumPy, Pandas, Matplotlib. So all these things are there, and whatever code is written within Pyiodide is actually compiled to WebAssembly. Which means, what does it mean? It means you can actually write a Python code, especially like Python data science machine learning code, on the browser without having Python installed. So you don't have to have Python installed at all, but still you can write Python code, because ultimately what has happening is your Python code using Pyiodide is getting converted into WASM, WebAssembly, and then it is successfully run on the browser. Which means even though you are writing a code in a very high level programming language like Python, your code would work actually as fast as a native application on the web, which is like, you can say probably written with JavaScript, or you can probably even say something like, you know, how assembly language is. Again, one thing that I would like to highlight is WebAssembly is not here to replace JavaScript, but to work very closely, so that people who do not code in a typical web language like HTML, CSS, JavaScript, they can actually write code on their own language and then compile it to WASM and then run it in near native speed. So that is WebAssembly. Pyiodide is what is making JupyterLite a reality. Now coming back to JupyterLite, what is JupyterLite? So JupyterLite is nothing but a Jupyter hub where the backend Python kernel is backed by Pyiodide. So Pyiodide, ideally, what is a kernel? Anytime you have a Jupyter notebook, you need a kernel, which means it's like the language engine that does a compilation. It's like a if you want R, then you need R kernel. Then if you want Scala, you need Scala kernel. So these kernels make it possible for you to compile or run a particular programming language on Jupyter notebook. So in this case, JupyterLab, Pyiodide is the engine. Our Python kernel is actually backed by Pyiodide. And then there is a JavaScript kernel, which is just an iframe, because JavaScript is a native web language. So it also enables you to store the notebooks locally, and there are a couple of other features that you can check it out. So what I'm going to show in this video is how we can just simply easily access JupyterLab, and then we can write a Python code, and then ultimately, of course, you can do some testing with yourself. So let me get started. So I will link this GitHub repository in the YouTube description, and also Pyodide's link at WebAssembly. Please make sure you check out all these things, and if you like JupyterLite, please give them a star and then appreciate them. It would mean a lot to them. So they've got two links. One is JupyterLab, the other one is like the retro lab, which is like Jupyter Notebook. Let me start with JupyterLab. So all you have to do is you have to click this thing, and then it's going to open. And then when it opens, you can see how much time it takes. It doesn't take a lot of time. So you can see it's quite fast. And then there are 3 kernels currently available. You have Pyiodide, you have JavaScript kernel, and you have got p5.js kernel. So I don't know JavaScript, so I'm going to simply get started with Pyiodide. So new. So I've got a new notebook, you can see, and I'm going to say import numpy as np, import pandas as pd, import matplotlib.plt as, what am I doing, pyplot as plt. Okay, so to make things simpler and easier, and you can see that it is getting executed. You can see this icon here, so it's getting executed. And to make things simply like slightly simple, I'm going to take a simple code to create linear regression in scikit-learn. Okay, let's see if we have any example data set. So we have got linear regression scikit-learn. So I'm going to copy these codes, and then we are going to paste it, and then we are going to run it. So we have X, and the shortcuts also work. So I just did control and Y, and then shortcut, and you have linear regression, and finally we have got the score or coefficient. Let's take the score, and then what am I doing? And then predict. Okay, I don't want to intercept all those things. Okay, I'm going to paste it. So at this point, you can see that we have got a working code of linear regression that uses scikit-learn, and we have got a bunch of arrays where we are saying x, y, and then we want linear regression. So let's run one by one. So first we are trying to import linear regression from scikit-learn, and this is running. You can see it's executing. While it is executing, I would also like to highlight a fact that you can see there is a notebook that was created 35 minutes ago. So that was a sample notebook that I created. So which means using local storage on your browser, so the notebook that you create will get saved on your local browser. So if you want, you can download it locally, so nobody is stopping you from doing that. But even if you do not do that, like, you might be worried, like, what if like a lot of times if there is a server which you do not have access to, maybe you don't get access to that thing. But it is not the case here. So something that you created before also still stays. So let's go ahead and then run the rest of the items, and then you can see it just ran just like that, and then we have got a predicted output. So I'm not going to explain you what's happening here. So the idea is to show you that you can simply write a linear regression, or let's say for that matter any machine learning algorithm or anything in Python data science stack, without having Python installed on your local machine. And even one greater thing is that you're doing completely on browser. So it could be your iPad, it could be your Chromebook, it could be your Android tablet, it could be anywhere, or even a mobile phone where you have got only a browser, so you can still do this thing. So that is one thing. The second thing that I wanted to highlight is something that I told you, like this is something that I created. What am I doing? Okay, I created when probably like 35 minutes ago, but it is still accessible. So what I'm going to show you is I'm going to quickly close this, go back, and then I'm going to open it again, so that you know that whatever we created is automatically saved. And that's what they're calling it, support for save settings, like offline notebook storage. So I'm going to open JupyterLab again. Once I open JupyterLab again, you can see basically it's actually a HTML file. What we are seeing, the rendered HTML file. So it's loading. and you can see the file that we saved 2 minutes ago, the file that we saved 37 minutes ago is available. So they've got a welcome tour if you want to attend, but other than that, all the settings that you see, everything is same. So you can even export the notebook. Like if I have a notebook selected, so let's say I have a notebook selected here, and oops, what did I do? Yeah, I have a notebook selected here. I want to export it. I can go here, click either download or export notebook as. I can download it. So you may not be able to see that, but my notebook is downloaded here. So I just downloaded it. So you can like leave it there then and there, or you can even download the notebook. And then the other advantage that you have is currently it supports only these 3 kernels, but because it's an open source project, because everybody is excited about WASM, it is highly possible that you would see support for a lot of other languages. That's another thing that I wanted to highlight. The other thing is it also supports multiple kernels running at the same time. So for example, like there are some Jupyter servers where you can actually have only one kernel at the same time. So like now I can have a Python kernel open. At the same time, I can open a JavaScript kernel. So you can see like I have a Python kernel. By this time you can see like there is a Pyiodide kernel combined. So now then I have a JavaScript kernel. So let me just put 2 + 2 is equal to 4. Basically it's getting executed on JavaScript, not on Python. But at the same time I can go here and then write some for oops, what am I doing? For I in range of 10, print I. Okay, it's an error because basically what I've done is I've written the code for, yeah. So you can see that it at the same time simultaneously you are able to use multiple languages. But again, now you might feel it is limited because you have got only 3 kernels. But I am very hopeful that the number of kernels would improve. So you have a bunch of other options, like you can see like what kernel it is. You can shut down the kernel. You have theme options, like you can change it to dark theme. So these are basic options that you usually get with Jupyter Notebook. And if you go to the project, you would see a lot of other requests where you can install extensions. Real-time collaboration is one of the latest features in JupyterLab, which is I think it's still in development phase. But yeah, there are active development. You can see the latest commit is yesterday, that was done yesterday. So there are a lot of good things coming out of it, and I am really hopeful about it. But at least for now, it is going to solve a huge problem where if you want to teach data science to somebody, or like, to be honest, like Replit is an amazing platform, right? Why do people love Replit? People love Replit because if you want to start with a new programming language, you don't have to necessarily go through the entire pain of setting up the environment, installing something, which is important, but it is not important when you are starting with the programming language. Same thing with Python data science. Like if you have to ask somebody to start with Python data science, they have to install Anaconda, they have to install they should know how to access Conda. Like some people may not like it, some people may not like the smaller entry barrier, but for some people it is very important for them to get started faster than having a lot of brick walls and then finally them dropping off. So this is a very good example of where you don't have to do anything in the environment side, setting up the your computation system, but you can just click a link, start with Python data science, and then also work it use it professionally, because Jupyter Notebook is there everywhere, wherever, whatever company you work for, either JupyterLab is there, otherwise like systems like Databricks is there, where that would also emulate Jupyter Notebook environment. So so all these things are there. So please try it out. I hope this is really useful for you, and I hope you really use it. And if you are interested in WASM, or if you are interested in development, please try to contribute to this project, because this is an open source project. You can see it is released in BSD 3 license, so you can see how you can contribute to it. Otherwise, share your love for the developers and share the word with your friends, and yeah, appreciate the developers on Twitter or LinkedIn, wherever you go. And again, you can use Pyiodide without JupyterLite. That's another thing that I would like to highlight. So if you want to try just Pyiodide, you can go here and then try Pyiodide. But I think it makes a lot of sense to use Pyiodide with JupyterLab, like not standalone. So have a look at this also, and then read more about WebAssembly. I hope you would find it useful and interesting. If this video was helpful to you, please let me know in the comment section. And if you have any feedback or suggestion from me, let me know in the comment section. Otherwise, please give a thumbs up, subscribe to the channel if you have not, and until next video, stay safe.